So, Electric Imp. I did have a really nice demo here with we were going to do audience voting and have a servo and have little counters and stuff. I was going to do it live. However, as anyone may have noticed, the Wi-Fi is even worse this year than it was last year. I think I'm blaming the drones. I think for sure they've got spread spectrum 2.4 and they're just blasting everything. So I have to tell you about it and I'll show you some stuff, but it won't be working. But anyway, you can play with it yourself. So what is Electric Imp? We're a platform to connect things to the internet. So a lot of people want to make connected devices these days, where you're just trying to make something for to open your chicken coop in the morning from bed, or you want to know the temperature somewhere else, or you want to stream some audio, or you want to do whatever. You want to program things. So we built a platform to do that, and we built it. We're makers and hobbyists, but we built it so we can use it, and also you can make things out of it and sell them. So it's kind of got two things. It's a commercial platform that you can use for free. And we don't charge developers. Never going to charge developers. This is still really loud. It's bugging me. Let's try that bit better. OK. So the way we do that, you need to connect to the internet. We connect using Wi-Fi. And we do it with something that's an SD format card. So this little card looks like an SD card. It actually has inside it all this stuff. It has a 32-bit ARM processor. It has a Wi-Fi chip. It has an antenna. Has all these power-saving components and stuff. And it's $25 if you buy one. So it's pretty cool for the cost of what you get. Obviously, it's an SD card, so you only get 9 pins. 2 are power and 1's ID. So in the end, you get 6 pins to play with on that one. But every pin can be analog. Every pin can be PWM. You can have 3 UARTs. You can do all sorts of fun stuff like that. But what it does is it's inside that card, it runs ROS, and it runs a virtual machine. So it's actually a real VM in there. Now, your code, you get to write on it. You write in a web browser. The IDE is online. And you can just type your code, hit run, and no matter where the imp is in the world, it will get that code and run it. As long as it's connected to Wi-Fi, it'll get the code. The imp connects securely to the internet and keeps a secure channel up, and then when you press build and run, it runs that code. Now, the weirdest place I've done this is I have left an imp in a bush 150 miles outside of Las Vegas, powered on 2 AA's, connected to a mall Wi-Fi, which was an open Wi-Fi. And I could build code for that and run it, even though it was in a bush outside Las Vegas, wrapped in duct tape, with a sign on it saying, "This is not a bomb." So it's weird for embedded programming. It's not next to you. It can be anywhere. But that's great, because it's always just after you've double-sided taped the Arduino to the ceiling that you realize you need to update the firmware on it. So it allows you to do that. It allows you to do this stuff. And because it's a VM, if you make an error in your code and the code crashes, no problem. You can get to it. Actually, see if I can show you. So if I'm on Wi-Fi, because I'm on 5 gig Wi-Fi, and that does work, hang on, I'll switch it back to this, see if we got the IDE. Nope, there we go. I'll put, it's going to be not much room, it's a very small, what the hell? Hello, when I press expand, I want it to expand onto this screen. Now I'm trying to hunt the mouse pointer. There we go, we got it. I'm going to get the bottom corner, because obviously it's not working. Bottom corner. This is great. Watching people drive computers is really annoying. So here's a unit I have actually just sitting in the office. I can write some code. Here I'm just saying hello. So I can say hello, make a Faire. And if the Wi-Fi is working, I press run. And that device is actually in Los Altos at our offices. And I just ran code on it. If I put an error in it, I go, oh, yeah, OK, whatever. It's dynamic language, so that could be a valid runtime thing. It's going, oh, you've got an error. And it's like, it's OK. I can just fix that error, press build again. It's compiled on the server, sent to the device, and the device reboots. And there we go, we're up. So it's kind of fun like that. You can actually program very, very forgiving. It's an object-oriented language. So you have classes, and you have strings, and you have tables, and you have all sorts of stuff that you'd expect for JavaScript-y type language. So I switch back to this. So yeah, the imp has I/O. It runs a VM. The OS takes care of all the hard stuff like interrupts and so on, and you get to write your code in that language. Very, very low power. It'll run connected to Wi-Fi on about 5-6 milliamps. If you want to sleep and wake, it'll go down to 4 microamps when it's asleep. So you can make something which will like take a temperature reading every 15 minutes, go back to sleep again, sending it to the cloud every 15 minutes, and it'll run for 3 years on 2 AA batteries. So you can get some pretty good power on that. So that's pretty good for that sort of type of thing. You can also even do audio streaming in and out. You can like set up a sampler, sample AC waveforms, sample a microphone, whatever, and stream that up to the cloud. So we have some demos over there, which again aren't working because Wi-Fi isn't, but the code's all online and it's all open stuff, so you can play with it. So that's one bit. But that connects up to our cloud, and our cloud has another VM. So this is the cool bit. You don't just get to write code on the card, you get to write code that runs within our cloud. And you get a megabyte of RAM there, and it doesn't burn any of your batteries. And that bit has a URL. So you can actually access your device with URL, even if your Imp is behind a firewall. You don't have to configure anything, it just works. It's all encrypted. You can do JSON parsing and all the stuff which is hard to do on a micro. You do that up in the cloud where there's loads of RAM, and it's running on an Amazon server and kind of easy stuff. So you get to split your problem. You do the cloud I/O and maybe like, fetching Weather Underground results and parsing it down just to the temperature, and then you send the temperature down to the Imp, and the Imp can then display it on a screen. So you get to do that split, and that's actually one of the problems with cloud-connected devices. Is usually you end up doing JSON parsing or something down on something with no memory. It's a pain to download, all that stuff. So this one, you get both, which is kind of fun. And that also means that there's no battery drain. Also, if you have a sleeping device, you can talk to the agent, which is what we call the VM in the cloud, 24/7. It's up the whole time. So it can like queue a message, and when the next time it wakes up, it can pull it directly down. So it's kind of fun. You can also do things like, if you're going to play a WAV file, you get the WAV file, you fetch it with HTTP, you strip off the headers, you do pre-parsing, and then send it down in chunks down to the device with no memory as it streams. So that's kind of cool. So that's kind of what it looks like again. You get the bits you write yourself live in 2 places. Then you have APIs for all sorts of things, for hardware, for cloud, for HMAC hashing, all the sort of things you need to do, things like OTP, TOTP, OAuth, stuff like that. And there's loads of example code for it. You write code in something called Squirrel, which is actually a video game scripting language. I don't know if anyone I think it's Left 4 Dead 2 uses it. We did have Lua, but Lua did my head in. I really couldn't get the syntax right. I kept using colons and dots the wrong way around. If anyone uses Lua, they'd know that. This looks a lot more like C. So you get 80K of free in here, 80K of RAM. After it's connected and secure and everything, you get 80K, which is a decent amount of space. You also get 128K to put your code in, which is, again, a decent amount of space. And the ones in the cloud get a megabyte by default. So what does it look like? This is like if I wanted to make a switch that would send a request to a web thing, to a website, this is what I'd do. I have a basically 3-line function here. I'm configuring pin 1. It's digital in with a pull-up. And when it changes, I send a message to the agent. And that's pretty much all I'm doing here. On the agent side, when I get a message from the device, I do an HTTP post, and that's it. And that is the whole thing. You're secure the whole way. You're HTTPS. Very, very free to do sort of the stuff you might need to make connected stuff. It's really, really easy to experiment with. The IDE, well, you've seen it, looks kind of like that. You get real-time logging out from both sides and so on. And the hardware looks like this, which if I switch over, and show it a bit more. So this is kind of a card. This is easy. The nice thing about this is there's a little dev board that goes with it. This has a power supply and a unique ID chip and a breakout for your pins. So these are like SparkFun, Adafruit, DigiKey, sell these, and these. The nice thing about it is you build this in. These are about $10, and you put the card in, and it will connect to the cloud service and run the right code for this board. The code is associated with this. So if I have one card and 3 of these boards, I can move stuff around. It'll just work, just by magic. It's kind of fun. But you have all the IOs, the PWMs, and so on out that side, and it's in a card form factor. The inside of it looks like this. Like I said, it's tiny. You can look at it on the booth. It's 0.4 millimeters thick board. It's kind of fun. There's another one which you can build into stuff, which looks like this. This has got more IOs. This again has the antenna, the Wi-Fi, the processor in. And we just launched a new one, which is this big, which has a Cortex M4, even more RAM and Wi-Fi built into it. The antenna has to be external, but it's also kind of hard to solder. But if you need lots of IOs, that's kind of a cool option. And that's what, this is like the breakout board for that. With you can see it's like 23 IOs on that one. And this is the antenna, is just on a PCB trace. So I said before that one of the nice things about it is you can build something, and then if you want to ship lots of them, it's actually really easy. And we have everyone from artists to GE using this stuff. So these are some of the people who use it. Things like Locatron uses for Wi-Fi connectivity. There's a quirky air conditioner, window air conditioner. I've seen it just launched. That uses us as well, so you can do like Nest type things. But Electric Imp is used to connect that device to the cloud. Budweiser made a promotional product which did this stuff. So did VB, Victoria Bitter. In Australia we have Haiku, we have the Mellow sous vide cooker, which is launching early next year, uses us. Ratio is a connected sprinkler system. So I can actually pull my phone out and turn my sprinklers on in my garden from here if I wanted. And that's in Home Depot in a couple of weeks, I think. So there's all these people who prototype stuff, and then you can go to production with the same stuff, which is nice, because if you want to like deploy new firmware to 100,000 devices, you just click a thing in the IDE and you're done. So it's like really nice for connected devices. You can keep them up to date in the field. Sorry I can't show you an actual wiring demo. I was actually going to be typing stuff in, and people are going to be voting and making the counts go up and down. But Wi-Fi, we're going to try tomorrow. We have some ideas up our sleeve, but we'll work on that. But if you have any questions, we're actually directly behind there. And I will get off stage because then we'll try and get back on time again, I guess. But thank you very much.